Hello coders, welcome back to GDG MMMUT, and today we will be discussing starters to 47 solutions. We will start with alternating array question. So you have an array A of n integers. You want to make it alternating, that is the parity of the elements should keep switching. For example, 1, 2, 3, 6, 5 is valid because it goes odd, even, odd, even, odd. So we have to find the minimum changes we need to make to the array to make it valid. Each change is of the form choose some index I and set ai to any integer you want. So here is the observation, like we don't matter, like it doesn't matter to us what is the value of that element. The only thing matter if it is odd or even. The second thing is there could only be two possible patterns: odd, even, odd, or even, odd, even. So our idea is simple. We will calculate how many changes are required to make the array follow the first pattern and store it in C1. And then we will calculate how many changes we are required for the second pattern and store that in C2. So as we iterate through the array, if the current index is even, for one pattern we expect an even number, and for the other pattern we expect an odd number. Similarly, if the current index is odd, the expected parity gets reversed. Whenever the current element doesn't match the expected parity for a particular pattern, we increase the pattern's counter because the element would need to be changed. So after checking all the elements, we will have the number of operations required for both the possible alternating patterns. Since we want the minimum number of changes, our answer is simply the minimum of C1 and C2. Now let's see this question, conveyor belt. There is a conveyor belt with n slots numbered from 1 to n. There is also a collection point at each end of the belt located at positions 0 and n plus 1. Each slot has a direction L which moves the object one position to the left, R which moves the object one position to the right. An object will be placed at slot P. It repeatedly moves according to the direction of its current slot until it reaches one of the two collection points. Before placing the object, you may reverse the direction of any number of slots, changing L to R or R to L. Find the minimum number of slots whose direction must be reversed so that the object eventually reaches the collection point. So in this problem, we have a conveyor belt with slots pointing either left or right and an object that starts from position P. The object keeps moving according to the direction of the slot it is currently on until it either reaches the collection point on the left at position 0 or the collection point on the right at position n plus 1. However, if the direction create a cycle, the object may keep moving forever and never reach a collection point. To avoid this, we are allowed to reverse the direction of any number of slots before placing the object, and our object is to minimize the number of reversals. Now if we want the object to eventually exit from the left side, then every slot on the left of the object must contain L. So while checking this possibility, we simply count the number of slots left to P containing R, because each of them we would need to be flipped. So we store this in LC. And same, if we want it to exit from n plus 1, we will count how many slots in this range currently contain L, because those are the slots that are need to be reversed to allow the object to move all the way from the right collection point. So we will store this in RC, and we will simply check which of both of them is minimum, and that will be our answer. Let's see this problem. Substring shift. You are given a string S consisting of lowercase English letters. You may perform the following operation at most once. Choosing a non-empty contiguous substring and replace each character in it with the next letter of the alphabet cyclically, that if A becomes B, B becomes C, and so on, while Z becomes A. All characters outside the chosen substring remain unchanged. Find the lexicographically smallest string that can be changed. So in this problem we are allowed to choose a most one contiguous substring and shift every character in that substring to the next alphabet character. So here as our goal is to obtain lexicographically smallest string, we need to think carefully about which characters actually might help us when they are shifted. So like for any character from A to Y, shifting it will only increase its value, like B to C, C to D, which make the string lexicographically larger. Here the only character that helps is Z, because Z changes to A due to the cyclic rule. So changing non-Z characters is never beneficial for minimizing the string. This simple observation simplifies the problem a lot. Here the optimal strategy is to find the first occurrence of Z in the string and then convert the entire consecutive block of Z characters into A. Since earlier positions have a greater impact on like lexicographical order, so the converting the earliest block of Z's gives us the best possible answer. So in the code, we first move through the string until we find the first occurrence of Z. Then as long as we keep encountering the Z characters, we replace them with A. So once the block ends, we stop because we are allowed to perform the operation only once on a contiguous substring, and we get our new string. Thank you.